Welcome back. This is Sachin again, and today we are going to discuss about PrivateDNS. So, consider a situation that you are in any of the EC2 instance, whether it's a public subnet or a private subnet, and you want to resolve or you want to access this public service, SNS in this case, via, let's say, this HTTPS endpoints. So it's like https://sqs dot and the region name and image on aws.com / the queue name. So either case, whether you are if you are like in your AWS VPC, this endpoint is resolved publicly, which means if you are in this EC2 instance and you want to access this endpoint, it should be publicly accessible from this subnet. So basically, the green color what you see is here is a public subnet, because via a route table the default association is to the internet gateway, and this is a private subnet, the blue color which you see over here, because via route table association this resolves to a NAT gateway, and via that, which is in a public subnet, and via that it gets a public accessibility. So if you want to access your SNS, this should be publicly resolvable, which means the traffic will travel from here to internet gateway, and then this SNS service is accessible. For some reason, if for security reason or compliance reason, there is no internet connectivity. Basically, there is no NAT gateway, or basically if there is no default routing to NAT, and this internet connectivity is not there, there's still another option, and I've covered that in detailed video for instance endpoint. These services you can inject via an ENI into your subnet, and if you want to access SNS, this interface endpoint provides you a separate set of DNS names. So please refer my video to get more details about it. But using those DNS endpoints, this will internally resolve these services. You do not need a public internet connectivity in this case. But what problems PrivateDNS solves is that you don't need to access those separate private endpoints, and even these public endpoints will be resolved to these private IPs, and the traffic will flow still using this interface endpoint to SNS, even if you are using these endpoints name. So that's pretty much about the architecture about PrivateDNS, and we will see it with an example. Thank you. All right, so we understood the architecture. So let's see it with the demo. So right now, I'm in my EC2 instance, but basically into a private subnet, this particular EC2 instance, and we can verify that this is the private IP address in private subnet. Okay, this one. So this is a private subnet B with this IP address 12.196. So this is the machine I'm already in, and because there is a connectivity via NAT gateway to internet gateway and internet, I can access internet from here. So basically pingworld.com I'll receive this packet. So there is an internet connectivity. In fact, I can say AWS S3 LS, and this will give me all my bucket names. All right, so as there is an internet connectivity, and in parallel I've also created a queue, and this is the URL for that, sqs dot, and I'm in the AP Southeast Region 1, Amazon AWS.com / the account name, and the queue name is my queue. So if we can go here, and we see there already one message there, but in fact we can publish a couple of more messages. So we can say send and receive message M1 and press send button. So this will publish the first message, second message, and third message. All right, if we go out and refresh it, we see there are 4 messages in total. So right, so in fact we can hit this particular command. I'll put it in the description of the video. AWS SQS and receive messages, and you give the same queue URL and basically all attributes, and you receive 10 at max 10 number of messages. So if you hit enter, you will see those messages coming over here. So basically this has full connectivity because I can access google.com, S3, and these SNSCR, SQCR, they all are resolved because there is a public connectivity. Now, all I'm going to do is to basically, remove this connectivity. So this doesn't have a public connectivity. So just go to VPC and then go to route tables, and this is the route table which default it goes to NAT gateway. I'm going to say edit route and then remove this association, save changes. All right, so now this connection you see over here is destroyed. Now if I say ping google.com, there's no packets received. Press Ctrl C or AWS S3 LS, it just hangs over there. So we can say there's no public connectivity over here. Now all I'm going to do here is to create a interface endpoint for SQ service. So let's go to your VPC, and below you'll find interface endpoint. Click on create endpoint. It's going to give, say, my IP. It's not for my endpoint. It's an AWS service, SQS, and then choose SQS. It's an interface endpoint. I'm going to choose the VPC where I'm working in. Additional setting. Okay. And I want to inject into this private subnet B in my subnet. So that's why I've chosen AZB and the subnet name. All right. Let me associate this security group. All right. By the way, so to enable private DNS, this option needs to be chosen, enable DNS name. All right, and click save changes. Create endpoint. Perfect. So I was actually expecting this error, and I deliberately want to show it to you that if you just go and try to check this option, this will result into an error, because for these options to work, the enable DNS host name should be enabled on a VPC level. So what I'm going to do here is, in a new tab, I'll open a new VPC and then go to the VPC where I'm doing this demo, and you see DNS hostname is disabled. And what typically it means is, let me quickly show you. If you go to EC2 and then click on instances and pick any instance, let's say this one, and you see there is no public IPv4 DNS for this. By choosing that option, you will get a public IPv4 DNS value over here. So that's what we are going to do over here is, so just click on action, add his DNS host name, check, and save changes. Now DNS host name successfully updated. So if you want to validate it, click back, and now this is enabled. Now all I'm going to do here is no changes in this screen, and again press create endpoint, and this time it will successfully create the endpoint for this. All right, so that's pretty much. Let's give a few seconds for status change from pending to available. I'm going to pause this video for a while, and once it is green, we can resume our video from here. All right, so I think I waited for a minute or two, and then I'm gonna click the refresh button again, and I see the status is available, so which means this endpoint is available over here. Now all I'm gonna do here is go back to my SQS, and the queue, I just want to push one more message, let's say M4, and send message. Now let's validate ping google.com. This should not work because there is still no NAT connectivity. I cannot access my S3 because this will go to the public zone, and then because there's no NAT, you won't send or receive any packets. However, if we choose this option, because now the private DNS has been enabled, though it seems to be a public endpoint, but because of that, internally it will resolve into the private IP, and via this ENI, and this channel, it will access the SNS service. Sorry, SQS service. My bad, this is SQS and not SNS. Perfect. So now we see that even there is no internet connectivity, we can still access the SQS service and without even changing these URLs. And that's what this private DNS is meant for. Hopefully you have enjoyed this video and learned something new. Thanks for being in touch.